In our last lesson, we ended up with the summary of trigonometric identities, and these are the ones that we discussed. Tan theta is identical to sine theta over cosine theta, and then we discussed the reciprocal trigonometric identity, the first one being cosec theta identical to 1 over sine theta. The second one is sec theta, which is identical to 1 over cos theta. And the third one is cot theta, which is identical to 1 over tan theta. Today we're going to progress with the study of trigonometric identities, and today we are looking at the Pythagorean trigonometric identity, and the first one being cos squared theta plus sine squared theta being identical to 1. Why do we call it a Pythagorean identity? Because we derive this identity from a right-angled triangle by applying the Pythagoras theorem. Okay, so if we have a right-angled triangle which has got its hypotenuse equal to r, its adjacent x, and its opposite y, then using the Pythagoras theorem would write this as r squared, which is the hypotenuse squared, being equal to x squared plus y squared. What we're going to do with this Pythagoras theorem, we're going to divide throughout by r squared. So if we divide throughout by r squared, our Pythagoras theorem, it will look like this: r squared divided by r squared, x squared divided by r squared, and y squared divided by r squared. Then r squared divided by r squared will give us 1, and x squared divided by r squared will remain as it is. Y squared divided by r squared will also remain as it is. Okay, so we're going to use this to derive our first Pythagorean identity. So we've got 1 being equal to x squared over r squared plus y squared over r squared. Now, by applying laws of indices, we know that we can write this as x over y everything squared, and we can write y squared over r squared as simply y over r in brackets squared. Then we will recall the following. We will recall that cos theta is equal to x over r from the right-angled triangle. So cosine is adjacent divided by hypotenuse, and if we square both sides, we're going to have cos theta squared and x over r in brackets squared. We will also recall that sine theta is opposite over the hypotenuse, so we've got the opposite here divided by the hypotenuse, and squaring both sides we're going to have sine squared and y over r squared, like that. Now look, what we have here, cosine squared, which is equal to x over r squared, is exactly what we have there. So in the place of x over r squared, we can comfortably replace that with cosine squared. And in the place of y over r squared, we can comfortably replace it by sine squared. So we have 1 will be identical to this one, which is cosine squared plus sine squared. That is how we derive our first Pythagorean identity. Our second Pythagorean identity is 1 plus tan squared being identical to sec squared theta. We derive the second Pythagorean identity from our first derived Pythagorean identity, which is cos squared theta plus sine squared theta being identical to 1. So what we're going to do in this particular case is that we're going to divide our first Pythagorean identity throughout by cos squared theta. So if we do that, cos squared theta divided by cos squared theta, we're going to have that. Then sine squared theta divided by cos squared theta, we will have that. Then 1 divided by cos squared theta, we're going to have this. And then if we apply our laws of indices, we can comfortably write cos squared theta over cos squared theta as simply cos theta divided by cos theta, everything squared. In the same way here, we can write that as sine theta cos divided by cos theta, everything squared. And we can write that as 1 over cosine everything squared. Now we're going to remember, we know that cos theta divided by cos theta will simply give us 1, which is this one here. Okay, 1 squared is 1. And we will remember that we already have learnt an identity, which is sine theta divided by cos theta, and that identity is tan. So here we'll write tan squared theta, and we know this reciprocal identity, which is sec. So we're going to write this as sec squared theta. So this is how we derive our second trigonometric identity. And our third Pythagorean trigonometric identity is derived in the same way. So it is cot squared theta plus 1 being identical to cosec squared theta. And to derive it, we begin with our derived first Pythagorean identity, which is cos squared theta plus sine squared theta being identical to 1. And then this particular time we divide throughout by sine squared theta, and if we do that, we have cos squared theta divided by sine squared theta, then we've got sine squared theta divided by sine squared theta, and then we've got 1 divided by sine squared theta. Okay, now these are identities. We know that tan theta is equal to sine over cosine, and if we reciprocate tan theta, we write it as 1 over tan theta. We're also going to reciprocate this side, which will give us cos theta over sine. So the sine will become the denominator and the cosine will be the numerator. But we know that this 1 over tan is what? Cot. So which means even that cosine theta over sine theta is cot. So we've got cosine theta over sine theta there, which will give us cot. So we're going to have cos squared theta. These two cancel out, giving us 1, and the reciprocal identity of sine squared theta is cosec squared theta. So this is how we derive our third Pythagorean identity. In summary of Pythagorean trigonometric identities, we have the first Pythagorean trigonometric identity, which we derived, being the cos squared theta plus sine squared theta being identical to 1. The second one is 1 plus tan squared theta being identical to sec squared theta. And the third one and last one is cot squared theta plus 1 being identical to cosec squared theta. Okay, and I'll leave you with these words. To enjoy trigonometry, to be successful in the quest of this study, you don't necessarily have to be deriving these Pythagorean trigonometric identities, but you've got to learn them off by heart. You've just got to know them the way they appear right now. If you neglect memorizing these, you will find trigonometry challenging. Okay, so leaving with those words, thank you.